Welcome everybody to Sustainable River Basin Management Module 1, Part 5, last part. We'll today speak about the Anthropocene, which is a subtitle from hunter-gatherers to a global geophysical force. We'll look at what happened to humankind in this particularly geological time. We are essentially speaking about Holocene, which is a geological time scale that covers the last 12,500 years, essentially the end of the Ice Age. And there's a particularity about the Holocene, which you can see here when we look at climate development. This is a graph that shows us on one axis our years in 1,000 years before, from today before present, and on the other axis we have stable isotope. In this case, the stable isotope ratio of oxygen in water. This stable isotope or stable isotopes help us to detect and reconstruct paleoclimates. And what we can see here very nicely is that our Earth has seen peaks, extreme events from very cold to very hot, again changing to very cold periods and hot periods over the past about 100,000 years. And then during Holocene period, we see that our climate actually stabilized at a fairly high or stable warm temperature. How do we know those temperature changes here? We were looking at ice cores from our ice shields, which are an archive of the climate. So what we also see, we can relate our climate changes to a migration pattern of human population. And we see that major migrations were always triggered during the cold seasons, during the extreme events of cold periods. So all of those were forced migration and the dispersal of the human population across the entire world. What we also see is that with the stabilization of our current climate, the climate that we live in today, we see the development of what we call the great civilizations across the world. Now, this particular period when our great civilizations started to develop and came into being is also called the Anthropocene, which is translated into the age of man. Let's look at what this Anthropocene actually means. Let's have a look at the Earth's atmosphere development as we know it today. We know that our Earth is about 4.5 billion years old. Notice that this is a log scale here, and obviously we have more detailed information in recent, for the last 2.5 million years, and information becomes more scarce, more uncertain the further we try to go back in our Earth's history. What we see is that the atmosphere changed and developed. So the atmospheric composition changed, but it reached a fairly stable, high, favorable condition for human development in the period that we call Holocene today. So let's keep in mind that changes in the atmosphere are part of the Earth's system, and we are just looking right now, when we talk about Holocene, into a very short time window of the Earth. Now, what is special about this Anthropocene is that it allowed the development of highly complex human societies. So it's a stable environment that, in a way, also is accommodating our needs in a perfect way. And as far as we know today, it is also the only state of the Earth system that can support our current societies. It also is the period where actually our human presence, our human activities actually have entered into a competition, a rival stage of global geophysical processes. And what this means, I will show right now. Let's try to understand this Anthropocene. And here we have a graph that was produced by Stephen et al. In 2011, showing on one axis the population growth, population numbers, on one axis technology increase measured in the number of patents, and on the third axis something called affluence, which is wealth expressed in terms of the world gross domestic product. Now, spanning this into a space or into a spatial frame, like in this case, we can see that our wealth, our human impact actually increased potentially from the 19th century onwards, and that it particularly grew to exponential dimensions from the 1950s onwards. Now remember what we have been talking about in previous lectures on our carbon-based economy. And this point where this acceleration took place, or started to, took place, we also call the Great Acceleration. And it actually goes hand in hand with the switch to our carbon-based, today's carbon-based economy. It also goes along with major technological advancements in which led us to the so-called green revolution, actually allowing food self-sufficiency, increasing at large scale food production with many problems associated to it, and major advancements in the health sector, which enabled a major population growth. Now, we can look, or we can take so-called indicators of this Anthropocene, and any of these, we can pick population, GDP, foreign direct investment. You can look at international tourism, McDonald's restaurants, paper consumption. It doesn't matter which one we pick. All of them will show a similar trend, which is extremely exponential. So in this exponential development goes hand in hand with what we have been talking about earlier, the switch to our carbon-based economy based on consumption, increase in consumption. Now, this is quite worrisome, and we will come back to this later again. We talk about that. Now, let's look at the distribution of that wealth. This is a graph that was produced and published by The Economist. You see here a change in world GDP on each previous year. And we have a subdivision here between so-called rich countries, the so-called BRICS countries, and other emerging countries, and a total which follows this red line here. And what we can see is, this only starts in 1998, but and goes to about today. The BRICS countries means, it's an abbreviation standing for Brazil, Russia, India, China, and South Africa. What you can see here is that overall we have an increase increasing trend of the GDP. However, with a lot of variation between years. And what we can also see is that this overall increase takes mostly place in the so-called BRICS and emerging countries, whereas in the so-called rich countries, the world GDP is actually decreasing and has seen a major breakdown in the year 2008, 2009. So what we can notice here is that our concept of rich and poor countries or developing and developed countries is not holding anymore the way we had established it in the 1980s or 1970s. Actually, the 52 countries of the world representing about 90% of the world GDP, and a major portion is accumulated in those emerging and BRICS countries, which have been less affected by the major financial or global economic crisis in the recent past. Now let's just look at those BRICS nations. What we see here is where those countries are located, and we see that many of these countries have major problems in literacy, education sector is in those countries not perfectly covered, and some poorly covered. We also see that we have a major workforce right now in some of these countries. More than 50% of the current population actually as an active workforce. Some of the countries have a very low workforce, but that accounts to a very young population. So in the very near future, that workforce will increase considerably, and life expectancy is comparably low compared to what we call the developed countries. However, those few countries actually bring together about 3 billion people and accumulate about 45% of the global GDP. That means that there's a considerable decision power accumulated in those countries in the way how resources are spent, how development pathways are chosen, where to engage, what priorities to set. And this also accounts to how energy sectors will develop, how resource use will be defined by those countries, which affects the global economy in large. So that is something we should really keep in mind before putting the finger to other neighbors in other continents. Now, there's a nice relationship between the Human Development Index and the ecological footprint. We have been talking about the ecological footprint earlier. This comes from a report produced by the WWF in 2006. There is a more recent report produced in 2013 by this WWF, but this figure actually is quite useful for demonstrating that particular relationship, and I didn't find it in the more recent document. So what you can see here is a relationship between human development and ecological footprint. So there are countries, many countries with a fairly high human development index, which at the same time have indeed a very high ecological footprint. So essentially they are drawing resources from the other areas, the other regions, to compensate for their over usage, over consumption. But we can also see that some of these, even in between fairly high human development indices, we have countries with a considerably lower ecological footprint. So it is indeed possible to achieve socioeconomic development and not compromising at such a high level our ecosystems carrying capacity. What we also can see is how some countries, some of the important major countries, BRICS countries, for instance, have increased their Human Development Index and how their ecological footprint changed from the year 1975 to the year 2003. And let's have a look at India. What you can see in the first place is a major population increase, exponential to what we know today. And what you also see is a major shift from a fairly low Human Development Index to a higher Human Development Index, whereby the ecological footprint did not increase. That is quite remarkable. So it is possible to invest in key parts, key components, which improve human and social prosperity without actually having a large impact on the ecosystems. And then we have countries which actually follow ways, strange pathways, which in a way reflects the issues of health, of political stability. Health, especially the impact of HIV and other large epidemics. Now, let's keep in mind that the Human Development Index is simply a global average. It's a measurement of the global achievements in health and social economic development. It does not really show us the changes in poverty alleviation, in overcoming inequalities. Now, let's look at climate change, because that is what we talked about earlier under planetary systems boundaries. And we were saying that climate change has a major impact on our survival, on biosphere integrity. What do we mean by the term climate in general? It essentially states or tells us the state of, or describes the state of the atmosphere in space, which means the physical and chemical state. So it includes temperature changes, changes in the chemical composition of our atmosphere. And it states the seasonal changes, and those seasonal changes are also called climate phenomena. One way known in this region, in India, are the monsoon systems or El Niño and La Niña events. And we also hear, very often, when we talk about climate change, we hear the term climate variability. And what we mean by climate variability are those temporal fluctuations around an averaged climate behavior. So we may use a mean annual long-term measurement and say what is our current temperature or rainfall pattern compared to this. It may be above this or it may be below and may indicate a drought or a flood scenario. So we have to keep in mind that this is an arbitrary time scale, and it's changed and applied in different ways for different purposes. Let's say for insurance purposes, different as compared to agricultural planning. And then there's a third term to climate change, which is the term weather, which simply is an expression of the atmospheric state in space and time measured at a daily time interval. So it's the day-night change, which essentially determines biological activity. So it's also quite important. Now, let's have a look at climate change and the chemical composition of the atmosphere. You know that the atmosphere essentially consists of three major gases: nitrogen, oxygen, and argon. And then there's a minor portion of trace gases, and this minor portion of trace gases is the one that is important when we talk about climate change and greenhouse gas emissions in general. Now, this trace gas composition here is changing. We know that our carbon dioxide emissions are increasing methane in our atmosphere is increasing. So this is what triggers major changes in our atmosphere and major changes that lead us to climate change. And then there's what you remember from planetary systems boundaries, a term called novel entities, which also influences or impacts this trace gas composition, which are emerging chemicals or micropollutants in the atmosphere and aquatic environment. Just to mention alone pharmaceuticals and personal care products, there are about 3,000 registered substances which all end up somewhere here in this diagram. Now, let's have a look at examples of green gas evolution. We don't have time to look into each and everything, but let's just look into examples. And let's look at carbon dioxide here. What you see here is, this was produced in 2007 by the Intergovernmental Panel on Climate Change, IPCC, is this increase, this exponential spike that we have seen in all the other indicators as well. And this is quite a preoccupation because it there are direct links to mass extinctions that have occurred before on our planet, before we came into existence. And there are different scenarios or models being calculated to try to predict the pathway under different scenarios. Let's a no change. If nothing has been done, no intervention be done, what the change will be, what the impact will be, and if we apply certain measures, how this will potentially impact or reflect on carbon dioxide emissions. So we get this wide range of possible concentration in the future. And then we have this pointed or dotted curve here, which shows us what is actually measured. And we see that we are fairly in between the extremes of what has been predicted. This is from the most recent report of 2013 produced by IPCC. You should check those reports and get a more in-depth information from that. And let's look at sea level change, another of the parameters indicating that climate change or temperature increase is taking place. We actually see here, again, the measured values and the predicted values. And we see here that actually the measured values by far exceed the projections. And we also see the wide range of predicted sea level changes, and again, the measured values here. So overall, we have about 2.9 millimeters plus minus 4.4 in sea level increase per year measured already. So along with the changes in our atmospheric composition, chemical composition, we also observe measurably already extreme climate events, and we have been observing an increase in our mean average or in our mean temperature, atmospheric temperature, and with that a shift takes place over which leads us to an increase in a decrease in cold extremes and an increase in a shift towards more extreme hot events. If you combine, or if you look at the variance of these temperature events, then we see that this curve tends to flatten, which also means that we end up having more cold extremes, and at the same time also more hot extremes in countries or in regions where we are not used to these extremes. So, and then we could have picked any other of these parameters, precipitation also, but we always have an overlapping effect of this. So if we combine, in this example, mean temperature and the increase in variance, then the result is overall more extreme hot events to be expected. And if there is a cold event, it will be also very extreme. So there will be fewer events, but extremer on the other end. Now, let's look at climate phenomena and just the monsoon system, because it's most relevant for this region here. There are several systems under different names, and I've picked India here. What you see in those is an increase in, there's a change in the monsoon pattern, and the most recent work group, technical work group of the IPCC in 2013 actually summarized it in this way, and I wanted to keep this so that you see the language, which is very carefully crafted and which shows how much uncertainty is there and how much worry also is in what is being observed and expected. So it's actually saying that taken together with identified model agreement on future changes, the global monsoon is likely to strengthen in the 21st century with increases in its area and intensity, while monsoon circulation weakens. So this is what the prediction is for our monsoon systems. Now, let's summarize what the Anthropocene actually means overall. It means that our total material wealth of the humanity has been enhanced. So there is poverty increase as well, but total global wealth of humanity has substantially enhanced. And at the same time, we face serious issues like the scarcity in critical resources, the degradation of ecosystem services, the erosion of our carrying capacity, and increasing inequality, poverty. Now, what is special here is that this is novel in its speed. The global scale, it affects everybody, and the actual threat not to a local ecosystem, but to the resilience of our entire Earth system. So, which takes us to the step that we ourselves have to fundamentally change our relationship to our planet and to our environment in particular. Now, I would like to conclude Module 1 at this step. What we have been saying and investigating is that our current economic model is based on growing consumption and sources to sink product life cycles or life systems, which is completely contrary to principles of sustainability. Our global wealth has exponentially increased with the beginning of our carbon-based economy. Resource depletion and pollution effects which have to be faced by today's generation. It's not an issue of tomorrow or next generation. It will affect us already. Planetary system boundaries are currently under development from a scientific point of view to create a scientific and political framework which will help countries to develop together, hopefully, a global sustainability agenda. And well, climate change impacts and the breakdown of the biological integrity are imminent. So I don't want to drop you at this stage with such a black out view. I want to also highlight what to be done under these conditions. Alternative economic models which decouple our human prosperity from consumption have to be developed and are in some parts of the world under development. There must be alternatives to our carbon-based economy. Energy systems must change. Our natural resource base based on carbon has to change. And there are some countries which actually work on this, and you may have read about it or may read about the German term Energiewende, which actually expresses a major, profound change of economic and social systems towards those initiatives, and that our economy has to work on resource recovery, mainly from aquatic environments, river systems, lakes, oceans, and so on. What can you do? You as individual, you should engage in professional fields that work towards any of these sustainability measures, and you could also reflect upon your own lifestyle because you know that our system, current economic system is based on consumption, means demand-supply mechanisms, and that is where you personally can make a change yourself. At this point, we stop and we see us again for Module 2. I would recommend you to watch this movie called Age of Stupid, and I would also recommend you, when you watch that, you can find it online, you can watch it at home, to reflect on these questions for yourself. This movie has been watched by more than 61 million people on Earth, and it has had its major impacts and shows that societies can be a driving force in lifting major changes, even economic changes. Thank you.